Hi there. Welcome to Intermediate Algebra. This is Unit 1, Section 2, and these are the guided notes for this. And what we're going to be talking about today is more solving equations, okay? Specifically solving equations with variables on both sides. Now, I'll let you read through the standards and the objectives for this section on your own, but let's just jump right into this video. Now, the first thing I want to talk about is the distributive property. And what that means is that we want to multiply the outside number by each number in the parentheses, okay? So that's the idea. So, usually what I do is if I see this, like 2 times the quantity x plus 4, I'm distributing the 2 into each of those, all right? And what I'm going to do is I'm going to write that as 2 times x plus 2 times 4, and that clears the parentheses and no longer has x plus 4 as a group, but instead we've got this, 2 times x, which is 2x, and then 2 times 4, which is 8, okay? And that's our answer for that. And all we're doing is just simplifying this, okay, where we distribute that 2. All right, let's take a look at the next one. Now, this one has got some negatives in it. Now, if you have a negative sign in front of this number that's next to your parentheses, that sign has to go with it, all right? So in this, I'm going to take negative 3 times 4x, and then here's where it gets weird. I usually, if I'm doing a negative times a negative, I'm still going to do this. I'm still going to put a plus sign and write that I'm taking negative 3 times then negative 5, okay? So if I take negative 3 times 4, that's going to give me negative 12x. And then, if I have like a negative times a negative, this is going to remain positive, and this is going to be positive 15, because negative 3 times negative 5 gives me positive 15. But one thing I want to do, let me do a third example out here. Let's say I have negative 3 times 4x plus 5, okay? Then if I distribute that negative 3 into here and here, I'm still going to get negative 3 times 4x, and then I'm still going to put a plus sign here, and I'm going to do negative 3 times positive 5. Now, negative 3 times 4 gives me negative 12x. Negative 3 times 5 gives me negative 15. Now, you can put plus negative 15, or you could do negative 12x minus 15. Okay, either one of those works. So the negative signs can get a little tricky. All right, let's take a look at this next part. Now, what I want to do is provide an example where we are solving equations with variables on both sides. So what that means is that, if I draw a line down the middle of my equation here, I have a left side and I have a right side. And I want you to notice that you've got variable terms on the left side and you have variable terms on the right, okay? So, one thing that I want to do, and there's no, definitive, steps that you have to take on this. You have a lot of options as far as how you want to go about this. But when I look at a problem like this, what I notice is that on the left side, I just have, a variable term 3x and a variable term 4x. And I can combine those, okay? So I can take 3x and add that to 4x on the left side. And that's going to end up giving me 7x. Now, I'm not doing anything with this negative 10 here, and in fact, I'm just going to drop that down. So negative 10, and then here's my equal sign. Now, on the right side of this equation, what I notice is that I've got a negative 2 that I need to distribute into this set here to x minus 4, and then I have this plus 9 on the outside. So I'm going to distribute that negative 2, and I'm going to write this as negative 2x plus negative 2 times negative 4 gives me positive 8, and then drop down my plus 9. okay? Now, from one step to the next, all right, so from my next step, what I want to do is I want to clean up this right side, all right, because I've got like terms. I've got like terms here with the 8 and the 9, and I want to combine those together. So I'm going to drop down my left side, which is 7x minus 10 is equal to, I'm going to drop down my negative 2x, and then I'm going to add 8 and 9 together. Now, 8 plus 9 is going to give me plus 17, okay? And from here, all right, what I can do is now we can start moving your variable terms to one side and your numbers, your non-variable terms to the other. So when I see this, and I've got a choice. I can move any one of these terms. And the more problems that you do, the more you begin to see these sorts of patterns. But when I see this, I want to move over my negative 2x. Here's why. Because I have a negative 2x here. If I want to move it to the other side, that means I'm going to add 2x to both sides. And I'm going to combine my variable terms. Now, the reason I did that was because I don't have to deal with this negative anymore. It turns into a positive 2x. And this 7 is already positive. So when I add 7x and 2x together, that's automatically going to give me 9x. So this cancels out. I get 9x here and then minus 10 here. Those drop down, and that's equal to 17. Okay? Now I have a two-step equation. And I've put my variable terms on one side. Now I just got to move everything over to the right. And I'm going to start that by adding 10. So if I add 10 to both sides, I'm going to drop down my 9x here. The negative 10 and positive 10 cancel out. 17 plus 10 gives me 27. Now, from here, I'm going to divide everything by 9, and then I'm going to drop down my x, and that's going to be equal to 27 divided by 9, which ends up giving me 3, okay? So that's the idea, all right? Now, do I have to go and do everything in order exactly the way that I did it? No. And so that's what's important, is that you practice this on your own and, make sure that you're doing legal math moves to arrive at this answer here, okay? And that's the idea. All right, let's take a look at this next one. Now, this next one is really important because it involves fractions. Now, one thing I'm going to do is I'm going to talk about how to clear the fraction. And the first thing that I want to do is identify what my fractions are. So I have the fractions 1/6 and 1/3. Now, when I identify those, what I want to find is the common denominator between 6 and 3. All right? And between 6 and 3, my common denominator is going to be 6. Now, the reason why I want to find my common denominator right off the bat is that I can multiply everything in this fraction, or in the left side of this equation, by my common denominator here and here, okay? And when I do that, I want you to see what happens, all right? What happens is I do this. I do 6 times 1 over 6 times d plus 1 plus 6 times 5, okay? You have to distribute that 6 into each of these terms. Now, what's weird is this whole thing itself is a term because I'm going to multiply it by this number 1/6. I'm going to do the same thing over here on this side. I'm going to distribute the 6 into here and here. So on this part here, I'm going to write 6 times 1/3 times 2 minus d plus then 6 times 1. Okay, so this is a way where you can manipulate this equation so that you don't have to deal with the fractions. Now, simplifying this, when we're multiplying fractions, I'm going to put the 6 over 1, we just multiply across, okay? So 6 times 1 gives me 6, 1 times 6 gives me 6, d plus 1 plus 6 times 5, which gives us 30, is equal to 6 times 1 is 6, over 1 times 3 is 3, and then you get 2 minus d, and then plus 6 times 1, which gives you 6. So now we have 6 over 6. Now I can simplify this fraction and this fraction. Now 6 divided by 6 ends up just giving us 1. So this divides out, and you're then just left with d plus 1. And even though that's in parentheses, you don't exactly need those parentheses, all right, because we have that 1 out here that's being multiplied. So now I have d plus 1 on the left side plus 30, and then that's equal to 6 divided by 3. That simplifies down to 2 over 1. So now that's a 2. I'm going to keep my quantity 2 minus d and then add the 6. So now what that's prompting me to do is distribute this 2 on the right side, and on the left side I can combine my like terms. So let's bring all this down. All right, so we've got d plus 1 plus 30 is 31. And then that's equal to, I'm going to do 2 times 2, which gives me 4. All right, so 4, and then minus 2d, and then drop down our plus 6. Now we can combine our like terms here, 4 and 6. So now the left side stays the same as d plus 31. And then here you've got, I can add the 4 and the 6 to give me 10. And then I'm going to drop down my negative 2d. So now we're at that point where we've got, you know, variables on both sides and numbers, okay? And we're at the point where we can start moving things around. So what I'm going to do, sort of, it doesn't, you know, either way we're going to result in a negative number here. But what I have is I have this negative 2d over here. My inclination is to just add 2d over, all right, to both sides. Now, it doesn't matter what you do here necessarily, because, you know, then d plus 2d is going to give me 3d plus 31 is equal to 10. I'm now going to subtract 31 from both sides, okay? And so now I've got 3d is equal to negative 21, divide by 3 on both sides, and then d is going to be equal to negative 7, okay? So that's how we want to go about this kind of a problem. Now this one, these problems, they're long, they're not very friendly, but hopefully you saw this problem in the beginning and you were like, oh gosh, fractions. We have a way to get rid of those so that we have an equivalent equation with no fractions, okay? And then it's a little bit more manageable to solve. Okay, the last one on this page, notice how this left side of your equation just has 4x plus 6. There's no multiple terms on this side. Now on this side, you do have the 2x plus 3. Now, watch what happens. If I distribute this 2 here into this, watch what I get. I get 4x plus 6 on the left side is equal to 2 times 2x is 4x, 2 times 3 is 6. Now notice how the left side is the exact same thing as the right side. Now if I go about this and I subtract 4x, I'm going to move this 4x to the left side, all of a sudden this cancels out to 0 and this cancels out to 0. So both of those cancel out to 0 and you're left with 6 equals 6, which gives you a true statement, okay? If you get a true statement, that means that you have infinite solutions. Okay, let's say, okay, so let's do this. Let's go, let's say, in a hypothetical world, that you get a false statement, okay? So let's just say that you had this. Let's say that you had x plus 3 is equal to x plus 4. And if you subtract an x from one side and to the next, and those both cancel out to 0, and you're left with 3 is equal to 4, well, that's a false statement. 3 is not equal to 4. Then you have what's called no solution, okay? So you've got some options there, all right? So these are special cases that will arise in these kinds of problems. Okay, on this page, we've got some word problems. And the first kind of problem that you're going to run into is what we call these mixture problems. So, Arabica coffee costs $28 per pound, and Robusta coffee costs $8.75 per pound. How many pounds of Arabica coffee must you mix with 3 pounds of Robusta coffee to make a blend that costs $15.50 per pound? So the first thing that I want to do is find out what we're being asked, okay? And it says how many pounds of Arabica coffee must you mix with 3 pounds of Robusta coffee, okay, to then make a blend that costs $15.50 per pound, okay? So what I want to do is come in here and label X as our unknown, and that's going to be the pounds of Arabica coffee, all right? And so that's what X is. That's what we're trying to find, okay? Now, here's what I know, is that I have $28 per pound for Arabica coffee, all right? Robusta coffee costs $8.75 per pound. So what I can do is I can take $28, all right, 28 times X, okay, plus 3, or I'm sorry, let's do $8.75 times 3 pounds, and that's going to be equal to a blend, all right, that costs $15.50 per pound. So $15.50, then times the blend, which is the amount of pounds of Arabica coffee with the already mentioned 3 pounds of Robusta coffee, and that's how we set up that equation, okay? Setting this up is pretty tricky, okay? Now, let's go ahead and simplify this equation. Now, the first thing that I want to do is drop down my 28x, okay? And then plus, if I take 8.75 times 3, that's going to give me 26.25, all right? Now, on the right side, I want to take 1550 and distribute that. So I'm going to get 15.50x plus 15.50 times 3, which is 46.50, okay? Now, from here, what I want to do is I'm going to move my x's to one side and my numbers to the other. And because I've got 28 here and 15 that I'm going to combine, I'm going to move this 15 over to keep my numbers positive. So what I'm going to do is subtract 15.50x from both sides. That's going to cancel out. And if I do 28 minus 15.50, that's going to give me 12.50x plus 26.25 is equal to 46.50. Now, I'm going to subtract 26.25 from both sides. And this ends up giving me 12.50x is equal then to 20.25. Okay? Now, if I divide both sides by 12.50, divide by 12.50, then I get that x is then equal to about 1.62, okay? And that's going to be my answer for this problem, because remember what we're being asked to find. We're being asked to find how many pounds of Arabica coffee must I mix with 3 pounds of Robusta coffee. All right, so what that means is that to answer this question, I would have 1.62 pounds of Arabica coffee, okay? And that's the answer, all right? Okay, on this next question, let's go ahead and read this. It says, Cameron pays 95 cents per song with his current music service A new music download service charges 89 cents per song, but with a $12 joining fee. Okay. Should Cameron switch to the new service? So, what I want to figure out, how many songs Cameron would need to buy for the two services to be the same. Okay, so let's do this. What we don't know is the number of songs downloaded. Okay, and we're really trying to find what we call the break even point. Okay, so if I look at this as plan A, which this costs 95 cents per song with the current music service. So that's the first one, all right? And what we're going to call that is we're going to label this as 0.95 times x, okay? And then we have plan B, which is a new service that charges 89 cents per song, but then a $12 joining fee. So it's a cheaper amount per song. However, you're spending $12 just to use the service. So what we're going to call that is we're going to call that 0.89x, then plus 12. And to find the break-even point with these two plans, you want to set these two things equal to each other. So when I'm going through and solving this equation, all right, what I'm going to do, I've just got one x term on this left side and I've got one on this right side. I'm going to move this 89 cent 0.89x over to the left side. So I'm going to subtract by 0.89x minus 0.89x. And then that's going to end up giving me 0.06x is then equal to 12, okay? And I can now divide by 0.06, 0.06, and from here, if I take 12 and divide it by 0.06, I get x is equal to 200. Now, what this means is that this number is the number of songs downloaded so that the plans are the same. Okay? So the question is that, to analyze, should Cameron switch to the new service? And what we know is that if Cameron downloads more than 200 songs, then the new plan is more cost effective. Okay? If he downloads less than 200, then the original plan is more cost effective. On this last question, all right, the table shows the rates of two taxi services. How many miles do you need to travel for taxi 2 to be a better deal? Okay, so one of the things is that you realize is that you have this initial fee and then you have the rate per mile. So if I want to, let's identify our variable here. How many miles do you need to travel for taxi 2 to be a better deal? So let's have x represent miles, or the number of miles. So number of miles. And if I have something for taxi 1, okay, well, we have our initial fee of $2.75 plus $2 times the number of miles. Taxi 2 has an initial fee of $4 plus $1.75 per mile. I'm going to put $2 here. Okay, and now what I want to find, again, is this break-even point. All right, to find out how many miles that we would need to travel for both of these to be the same. Okay, so taxi 1, okay, let's do this. Let's subtract 1.75x from both sides and solve this equation for x. And so we're then going to get 2.75 plus 0.25x is equal to 4. Now from here, I would want to subtract 2.75 from both sides. And so that's going to end up giving me 0.25x is equal to 1.25. Now, if I divide both sides by 0.25 and 0.25, I get that x is equal to 5, okay? And what that means is that 5 miles traveled means that both taxis would cost the same. Okay. Now, what I know about taxi 2, because it wants to know how many miles before taxi 2 is better, taxi 2 has a lower rate per mile, but a higher initial fee. Taxi 1 has a lower initial fee, but a more cost per mile. When you have a lower rate, that taxi 2 is going to be in the long term. So if it's more than 5 miles, then taxi 2 is a better deal. All right. I hope you enjoyed this video. Please reach out if you have any questions. Thanks a lot. Bye.